Welcome back, Math Ninjas. We're talking about exponents. This whole thing is called 2 to the power of 3. And the pieces of this are the 2, the big number is the base, and the smaller number up here is the exponent. 2 to the power of 3 means 2 times 2 times 2. So 2 multiplied by itself 3 times. It is repeated multiplication. The way that we're using this, that we're going to be looking at exponents, would be in this situation, looking at a problem and sort of simplifying it by rewriting with exponents. So what is 7 times 7? I'm sorry, negative 7 times a negative 7 times a negative 7? How would we rewrite that? So we'll start with that one. And so it's not asking to to solve it, like a negative 7 times a negative 7 would be 49 times a negative 7 would be 343. It's not asking that. It's asking to rewrite using exponents. This is what it wants: to the power of 3. Negative 7 multiplied by itself 3 times. So rewriting it here, negative 7 is the base, 3 is the exponent. And note that the negative sign is within the parentheses. That's super important. The problem would be very different if the parentheses weren't there. It would have a different meaning. Okay, so here we've got a half times a half times a half times x, and we can clean it up by rewriting it with exponents. And in this case, we're going to say a half is multiplied by itself 3 times. And then x is multiplied by itself 2 times. So 1/2 to the power of 3, x to the power of 2, or x squared as we call it as well. These are rewritten using exponents. They have the exact same meaning. And it's what if it's asked to rewrite using exponents, that's what we are looking for. A couple other ways that we'll work with exponents. If you have negative 2 to the power of 3, what is that? So that is saying now we want to evaluate. So not just expand it, which is negative 2 times a negative 2 times a negative 2. I'll just do that, but also then give the answers. So a negative 2 times a negative 2 is a positive 4. 4 times a negative 2 would be a negative 8. So that is, those things are equivalent. And then here's that other situation. So what this is literally saying is 2 to the power of 3, and then the negative of that. So what it's literally saying is negative and then 2 times 2 times 2. What is this? So 2 times 2 is 4, and 4 times 2 is 8. And then the negative sign comes in after that. So it's actually the same here, but that would not always be the case. So if it was 2 to the power of 4, if they were even, if it was an even exponent, it's going to change it, okay? So just keep that in mind. In fact, I almost want to do this. I'm going to go ahead and extend this example problem. So now let's do the same thing, but to the power of 4, and see why this makes a difference. Okay, so negative 2, there we go. So now we've got a negative 2 times a negative 2, positive 4, times a negative 2, a negative 8, times a negative 8 times a negative 2 is 16. So in this case, it becomes a positive 16. These things are equivalent. Here you've got 2 times 2 is 4, times 2 is 8, times 2 is 16, and then the negative. Then we are subtracting it, okay? So here it becomes a negative 16, where here it is a positive 16. Notice the entire difference is because the base here is a negative 2, whereas here the base is just 2, and then the negative sign. This is like order of operations stuff, right? Exponents before subtraction is kind of how your brain is thinking about it. Speaking of order of operations, that is the last example we're working with here. The first thing is exponents. We don't have any grouping symbols. So we would say 3 times 3 is 9, times 3 is 27. 8 to the power of 2, take away 64, divided by 2. That would be the first step. Now here's when you get into your order of operations, division before subtraction. So 27 is take away 32. And then this is equal to a negative 5. Okay, so those are the different ways we're thinking and working with exponents. And here are our practice problems. 1 and 2, rewrite using exponents. 3, 4, 5, 6, evaluate. So what are these equivalent to written without exponents? All right, take notes, add to your journal, and let's do this.